Hello everyone. It's great to have so many people interested in chaos and chaos engineering itself. So we're gonna spend upcoming 45 minutes talking about it. My name is Bartek and I'm a director of cloud engineering at Pegasystems, and today with me is Aga.
Hi everyone, I'm Aga and I'm cloud development engineer at Pega.
Okay, so before we start, first question, how many of you heard term chaos engineering? How many of you ever tried it? How many of you are working in an organization that is actively using chaos engineering? No surprise. So it's something that is actually, we are talking about it, but we are not using it, when in fact it's very useful in many aspects of running organizations, services, etc. So there are three things we would like to take from this this presentation. So number one is about what chaos engineering is. What are its principles? What is history, to be honest, because it's very related to chaos theory. So this is the first thing. The second is actually to convince you that chaos engineering is useful. So we're gonna be trying to answer the question why we should be using chaos engineering. And this is not only for you, this is also for you to use in discussion with other folks in your organization once you all are already convinced to do chaos engineering. So you go to your manager, you go to your, I don't know, CFO, CTO, whoever. So you can have exact reasons why you would like to have chaos engineering in your organization. We would like to give you those reasons. So this is the number two. And number three, we're gonna be showing very simple demo of how you can run experiment using AWS Fault Injection Simulator. It's not the best in-class tool to do that. There are other better tools actually to run chaos engineering experiments, but this example is gonna be super simple. We would like to show you how easy it is to do that and what kind of benefits you can get even with very simple infrastructure. So this is number three. Now, with that being said, I'm going to pass to Aga.
Okay, so let's start with chaos. According to the Oxford Dictionary, chaos is a state of complete confusion and lack of order. And that's why people are scared of it, even terrified. As human beings, we crave certainty, and to tame the chaos, we started to getting to know it better. The first person to start the battle with chaos was Henry Poincare in 1903. By his calculations and theories, he discovered sensitive dependency on initial conditions. Unfortunately, his approach didn't get a proper recognition for almost 60 years. There was also another guy called Edward Lorenz, who was working on weather forecasting models, and he came up with a great term. You may have already heard it because there is also the movie with the same name, the butterfly effect. The effect simply says that if there is a butterfly somewhere, let's say in Brazil, and it flaps its wings, then somewhere else, for example, in Texas, it will start a tornado or a storm. Fun fact. Originally, Lorenz wanted to call this effect the seagull effect, but to make it more romantic and poetic, he stuck with the butterfly. Concluding, we think we can predict the weather, but even a small change in condition or unknown variable can make a huge impact. Do you know from which movie is that scene? Exactly. Yeah, so here is a Dr. Malcolm, and he is a mathematician who is specializing in chaos theory. What he is doing here is explaining to the paleontologists its theory. Example that he used is about the drop of water. So he put a drop of water on her hand, and they observed the path. Then he repeated it, and they put another drop of water, and they also observed the path. You may expect that the path may be the same, but it may not happen. Why is that? There are many factors to consider. Skin fraction, orientation of your hair at the moment, and some skin imperfections. So even that small thing can vastly change the outcome. Speaking about the imperfections on your body, according to the science, if the surgeon makes a perfect incision, it heals much worse than the third chaotic one. Okay, so those examples might not be applicable for you. So think about those small habits, those small things that you are doing every day. If you look at them one by one, they seem like nothing. But if you gather them, they make a huge difference. And it's the same with microservices. In the complex systems based on microservice architecture, when, let's say, one service has some problems with network, latency, or simply it's down, it can disrupt work of other services. And there are two kinds of systems, unpredictable and chaotic one. With the first one, we are not able to predict its behavior in time. With the second one, from mathematical point of view, we are able to do it, knowing all the variables that influence the system. You may now ask, why are we talking about chaos theory in chaos engineering? The answer is simple. The distributed systems that are used in IT are complex systems, which implies they are chaotic. So imagine that there is a change in operational conditions in one system. Then it may affect the other. But it's not only about the technical side, but also about the people side. So imagine that you had that huge party on Sunday, and on Monday morning you are going to work. I assume that you didn't get a proper sleep that night, so it may affect the quality of code that you are writing. And even such a small factor can affect the system. So in chaos engineering, chaos engineering is the discipline of experimenting on the distributed system in order to build confidence in the system's capability to withstand turbulent conditions in production. It simply means that in the distributed system, we run some experiments to make sure that the system is resilient. And now, let's briefly talk about the chaos engineering history. So, in 2008, Netflix, who was quite a young company at the time, suffered from well-known and extremely tough outage. They were down for 3 days. That was the moment they decided they wanna move to the cloud. They wanna use AWS. And they did that. That was the moment the chaos engineering was born at Netflix. Probably there were some people who did this before, but it was never formalized. So, what did they do? They started to change people's mentality and created a tool called Chaos Monkey. What was this tool doing? Just imagine that you have a monkey and you are giving it the gun. Then you are closing it into the server room. And it starts randomly killing your servers. That's exactly what this tool was doing. And it was very successful. So they created another one called Chaos Gorilla, eventually creating Netflix Simian Army in 2010. What this tool was doing was just testing the resiliency, reliability, and security of its AWS infrastructure. In 2014, first person was hired to the role of chaos engineer at Netflix. Over the time, more and more companies started to introduce the chaos engineering tests as looking at the great success of Netflix. There was also a conference in 2018 organized by founders of Gremlin. Gremlin is also called as a failure as a service. Okay, you may ask, why did we put it here in timeline? Because people who were founders of Gremlin also worked at Netflix at the time chaos engineering was born. so they know everything inside out. Also, we put here AWS fault injection simulator, as we will do some experiments there. But Netflix is not the only company that introduced the chaos engineering. There is also another streaming company, Twitch, online auction service eBay, platform for ordering meals Just Eat, digital mobile network companies like Orange and T-Mobile, and some financial organizations like Goldman Sachs and Santander, and many, many more, like Disney Plus, Slack, Under Armour, Walmart, Uber, Alaska Airlines, and even such a serious organization inside the US Army, like US Air Force. So let's talk a little bit about chaos engineering principles. About the building hypothesis around the steady state, we'll talk a little bit later. So let's skip to second one. You want to be as close to the real world as possible. So to as close to the production environment as possible. But let's face reality. If you start on the production environment, you will most likely fail. So start slowly with the integration or even development stage, and then move to higher environments slowly to the production. And automate those experiments. Think about them as about the deployment process or some code quality gate. Run it as a process. Start slowly with one component. Be agile. You don't want your system to explode. And remember, chaos engineering doesn't cause the problem. It reveals them. So, how to start thinking about the chaos engineering? There are some questions that you need to ask yourself about your system. The first one, is your service really ready for the real world? What does it mean? So it simply means that most of the bugs are fixed and the system is working steadily. If it's in place, you can move on. If no, then do the needful. Fix the system. Then ask yourself if you have monitoring in steady state. Why? To check what resources are consumed during the steady state. What is the typical load, and do some conclusions. You can use simple set of parameters like CPU usage, memory usage, pod availability or latency, and so on. If monitoring is in place and you are confident with your system resiliency, then starts chaos engineering. And how that kind of experiment should look like. So, knowing your steady state, you can make a hypothesis. Let's assume that my system is Kubernetes deployment with 4 pods. My hypothesis is that only with 50% of my pods working, my application will be still working. Then I run the experiment and check if everything was all right. If there is still a room for improvement, then I do that and run the experiment again. If everything goes okay, then I can make another hypothesis and run another experiment. Now let's talk why to do that.
Okay, so now we know what chaos engineering is exactly. Let's talk about why we need it in our organizations. And we're gonna cover this topic circling around this nice circle in the center of the slide. So it's gonna be a story about success of organization. You are probably a part of success of the company, success of the team that is owning some kind of service. Yeah, but we're gonna be trying to take a look from the high level perspective. So there are 3 things that we would like to talk about that actually affects the success of your organization. So it's gonna be about resiliency, about reputation, and about money. Since money talks, let's talk about money in the end. So let's start with the first one, resiliency. what you can see on the screen is a survey which is talking about average numbers of high severity incidents, so basically SEV0, SEV1. So when production is down, when there is a huge business impact of the problem that you encountered there. Per month. So as you can see on the screen, about 81% of companies are having between 1 to 10 such incidents, which is pretty high number. Now, why we are talking about this? So resiliency is having, at least in my head, two meanings. So one is about, of course, technical resiliency of the service. So how easy your service can heal itself in case of there is any problem. Yeah? So this is what chaos engineering is all about. But this is also about resiliency of yourself. No one's like to be called in the middle of the night to fix some problem. No one would like to be under the pressure working with client in the middle of the night to fix something. This is the resiliency in the meaning of your own health and your own well-being in the organization. So this is equally important as, of course, technical resiliency. This is why we're talking about it. So what you can see on the screen right now is a screenshot from Down Detector website, which is showing how single outage may cause problems with different services. So this is actually in 2021, I guess it was 7th of December, if I recall correctly, when AWS had a really huge outage. Now, as you can see on the screen, it affected not only Amazon itself, but also other websites like Disney, Sirius, McDonald's, Prime Video. But this is not everything. It had even bigger impact. So, for example, Adele. I don't know who likes Adele, the singer. Is there anyone who is a fan? No. Oh, great. Bad example then. But yeah, she stopped selling tickets for her tour for one day because of this outage. There were people complaining that their flats are full of dust because the Roomba robots were not working. They couldn't connect to internet. There were also cats getting depression because some cat feeders were not working, those that were connected to internet. So they were starving, basically. Huge, huge impact on a different parts of life. And you can even imagine how many connections this single outage revealed that we have. So chaos engineering definitely can help with your services being resilient to that kind of problem. So for example, Netflix, who is also using AWS, during this outage was working pretty fine, to be honest. There were no like big complaints. There were some, but the disruption was not that big. So this is the first thing, resiliency. The second, reputation. So something that is not very often measured, we're going to be talking about money on the next slides, but something that is not very often measured is actually reputation and the effect of any outage on the reputation of your company, of your product. So, for example, let's say that you're a client of some bank and the IT system of the bank that you're using, let's say, let's face it, we like to use modern technologies, we like to use applications, we like to have an easy way to do some payments, etc. Let's imagine that you're a client of a bank that is having a system that is very disruptive, is not having a good resiliency. And there is another bank that is having exactly same offer, but its system is way better. Would you switch? I did. So basically, this is about chances that the company is losing because their systems are not resilient. So this is all about reputation. Having those two covered, let's now talk about money.
So as you all know, time equals money. So what is mean time to resolution? It's the time within company or a team is able to fix the problem. Why is it important? So imagine that you want to buy something online and you found two similar offers with the similar price. You click on the first page and it's loading and loading. Wait maybe 15 seconds, you refresh the page and it's still loading. Most likely, you will go to another page and buy it there, never coming back to the first one. So for almost 80% of the companies, it took 24 hours to solve that problem. And let's dig into some statistics. They may differ based on the industry, but for also 80% of the companies, the cost of 1 hour of downtime starts at $300,000, reaching in extreme cases even to more than $5 million. Just to let your imagination work. Imagine that you are putting $20 every day to your piggy bank. To save $5 million, you would have to gather those money for at least 700 years. A lot, isn't it? And let's see some most famous downtimes. So in 2015, Apple lost approximately $25 million for the 12 hour of downtime. What do you think? How many did Delta Airlines lose during 5-hour downtime next year?
Any guess? 5 hours.
More. Yeah, even more than 100, because they lost $150 million. So quite a lot. And let's see the trend. So as you can see here, on the next years, the cost of the downtime is rising. So let's see at the first one. The company paid 60. Oh gosh.
Yeah,
Could you take this one?
Sure. So basically, what you can see here is a trend of what is happening on the market right now, in the context of how much companies are losing on the outage. This is not per hour. Yeah, this is basically total cost of single outage for the companies. So as you can see, the trend is very clear. Like the outages that are causing under 100,000 loss is decreasing over the time. What instead is going up are those outages that are causing over 1 million or more than 100,000. So this is a clear trend. There might be different reasons. It might be related to inflation or different other factors. There is a nice report, by the way, from where this is taken. I found it like yesterday, to be honest. Where they're trying to explain the trend, and this report actually is having some other statistics about it, but the trend is clear. It's hard to discuss with the data. So basically, if you are going to talk with someone from your organization who's going to pay for introducing chaos engineering in the organization, show them this if they're going to be arguing about money. Yeah, how much money they can actually prevent from being lost thanks to chaos engineering. So now, since we are having question why covered, let's jump into a very simple demo of how you can run chaos experiment using AWS Fault Injection Simulator. And as I've said, it's going to be brain simple. So don't expect too much. But the fact is that we would like to show you something that you might not be seeing in the first place, but might be actually very interesting. So we're going to be using AWS Fault Injection Simulator, but of course there are plenty of other tools on the market right now that you can use. We already mentioned about Gremlin. This tool has been created by founders, by people who are working at Netflix. So it's pretty mature, I would say, when it comes to its capabilities. But it's of course paid offering, so it's not for free. There is Litmus, which is actually open source, and it's pretty nice tool. Also quite sophisticated, especially in the context of Kubernetes. And there are plenty of other tools like Chaos Mesh, Chaos Toolkit. Azure is having its own Chaos Studio. Fun fact, I guess that I've been checking this recently, but GCP is not having anything dedicated to its own clouds. Azure is having. The Chaos Studio, AWS is having its fault injection simulator, but GCP is not having something which is comparable to those tools. Talking about AWS fault injection simulator, so it's basically a service that AWS gives you. It's easy to use as any other of AWS services. It's having some safeguards. You have some actions, targets, templates, but you're gonna see it during demo how it actually works. What are we gonna do? I told you it's gonna be simple. We're gonna deploy EC2 instance using Terraform that is basically serving some content. That's it, nothing else. It's gonna be having some tags, and we're gonna try to run experiment against this setup, and then we're gonna create infrastructure which, at least in theory, should be more resilient. But this is gonna be a second step. So let me first very quickly run a Terraform to deploy our first setup. Hopefully it's gonna work. Sorry. And in the meantime, I'm also gonna deploy at the same time also the setup for the second infrastructure, because when it comes to deploying ALB, it takes a while. We don't want to wait too much. So let me do that. It's applied already. I forgot to destroy. Awesome. So this is what we have. Let me quickly jump into what we have in the Terraform. So as I said, yeah, we're gonna deploy some instance. What is important, it is having some bootstrap file. I'm gonna talk about it very quickly in a second. And it's having a tag to be destroyed set to step 1. There's some security group and things like that, so we can expose to the internet. That's it. And the bootstrap script is very simple. It's installing Apache. And it's serving some content with this conference logo, to be honest. So that's what we have. Now let's check if this is deployed. Yes, it is. And let's see in our browser if actually we are having some content being served already or not. It's loading. That's great. We have our website based on EC2. Yeah, very simple. Before we create an experiment, as Aga mentioned previously, we need some observability in place. It's gonna be, again, very simple observability. There is a Python script that I created where you can just paste some IP address or URL, and it just hitting the IP or URL and just checking response. That's it. So very simple. We don't need to overcomplicate it. So yeah, response to 100 means everything is fine, website is working, something else means that it's not working. Yeah? And it also says when it's back. So having that in place, let's now just make it a little bit bigger and let's see how we can actually create a very simple experiment. So we go to AWS Fault Injection Simulator. We create first something that we call experiment template. I have one already when I was testing this, but let's create a new one. So what we can do? We can do some, put some description, of course. Web resiliency. Let's call it that way. Now, what we can do in Fault Injection Simulator is that you tell about actions and targets against which those actions are being run. So when it comes to actions, what we're gonna do is we're gonna just terminate an EC2 instance. This is gonna be our experiment. So basically Chaos Monkey, yeah? But this time Chaos Monkey is destroying every EC2 instance that is having a given tag. So as you can see, as an action, you can choose from a different types of resources that are available in AWS. So for example, you can, we're gonna be of course targeting EC2, but if you look at EKS, yeah, you have a set of predefined actions that you can actually simulate. So like you can simulate pod IO stress, you can simulate memory stress. You can simulate network packet loss, so different predefined set of actions that you can run. Yeah, the same is for other services and other types of resources. So, for example, for network, you can simulate network disruption. What else interesting do we have? For RDS, there is only 2 actions, so not very, not very maybe useful, but still. You can try to simulate failover of DB cluster if you need one. There is also possibility to write your custom actions, especially against EC2. So you can use basically SSM to run some custom script, but this is a different thing. We're not gonna be covering this. What we need for our EC2, we need to terminate instances. Yeah. So this is our target. This is created by default. Automatically by a fault injection simulator. In our case, we're gonna edit, and what we're gonna do is that we're gonna select EC2 instances based on tags. In this case, the tag that we have is to be destroyed. Hopefully that I didn't make any typo. And value is step 1. So it's gonna select all EC2 instances with this tag. You can also put some additional parameters if you want to play with fault injection simulator. You definitely need to select IAM role to run it. You can put some stop conditions. You can send logs to S3 bucket or CloudWatch. Everything you can configure here. We're not going to be doing that. We want to keep it very, very simple. So let's now create this experiment template. Before we run it, let's go to EC2 instances. We should be having plenty of them because there are also EC2 instances deployed for the second free, yeah, as expected, for the second steps. But you can see that this instance is having to be destroyed set to step 1. This is what we want as a target. So we just click start experiment. Our hypothesis is, of course, that website is going to be down forever. Yeah, that's what we expect. So the experiment is started successfully. So when we go to our monitoring script, where is it? Yeah, you can connect to host. Very easy. Website is not resilient at all. There is no mechanism that can make it automatically back to life. So this is what we have. Now let's take a look at slightly improved version of our website. So what we're gonna, again, what we just deployed is basically a setup where we have some ALB in front. We are also having auto-scaling group, which is basically by default having two EC2 instances. And it's going to deploy those instances with the tag called to be destroyed, set to step 2. So, in theory, this should be more resilient architecture, since we expect that auto-scaling group is going to bring back EC2 instances to serve the content. Yeah, this is our expectation. So let's first see if our website is really working. So let's go to load balancer. Let's try to open it in the, sorry, it's here. Let's try to open it. Hopefully it's gonna show exactly the same content. Yes, it is. Awesome. Let's set up our monitoring once again. This time we're gonna be pointing to ALB itself. We started monitoring. Now we can run the same experiment. Of course, changing the template itself, because this time what we would like to do is actually we would like to target instances that are having to be destroyed, set to step 2. So let's update. And now let's start the experiment. And see about results. So hopefully as soon as the experiment is done, we should start seeing here the other response than 200. Yeah, we're already seeing 502. And now, let's wait when the website is back. Since we are waiting, we've been talking a lot about money. And my question to you is, we'll be talking about money in the context of hours and general outage. Who can guess how many dollars we lose in average by during 1 minute downtime? Give me a number in dollars. How many dollars we are losing? Okay, 10,000. Okay, so like two different nets. Anyone else? Any guesses? $100. 100K. Okay, not that much. Not that bad. Hold your horses. I found two statistics that are actually they were trying to come up with the answer. So there is one from Gartner. It's from a couple of years back. It's saying that it's 5,600 per 1 minute of downtime. There is another more recent that I found from some kind of institute. I don't trust them too much, but they are saying it's about 9,000. So in average, if we do something in between, we can say that per 1 minute of downtime, it's about, let's say, $7,000. Yeah. And now, let's see and wait. Let's see how many minutes we actually have until our resilient website, which is based on ALB autoscaling group, is gonna be having. And this question is about how much we lose during 1 minute is exactly in this context, because in theory, we created kind of resilient, or at least more resilient setup here, yeah, using ALB autoscaling group. But still, it's almost 2 minutes that we lost until our website is back, which means that some kind of client who tried to use it, who potentially might stay with us, because let's say we are a shop that is selling something, who might stay with us, it's probably no longer using our website, and we, in theory, on average, lost $14,000 only because of that. And now, with this very simple setup, because it's super simple, yeah, you have just a few components here. Running this chaos experiment, you can now start thinking, what can I do to make it better? Maybe EC2 is not a good one to be a backbone for my shop. Maybe I can have AMIs that are having pre-installed Apache, because this is also taking time to warm up EC2. Yeah, maybe I can use some other infrastructure under the hood to serve my website. So, very simple case, but still many things to consider. And with that being said, that's everything that we wanted to cover today, so thank you, and we are waiting for questions.